Look, I have taken another problem from GATE 2006 paper. The problem gives this decision matrix. Say, these are the they have given that a firm is required to procure three items PQR. These are the items, three items PQR, and the price quoted for these items in rupees by supplier. These are the supplier S1, S2, and S3 are the suppliers is given in the table below. The management policy requires that each item has to be supplied by one and only one supplier, only one item. That means 1:1. Only one supplier can supply only one item. So you have to find the minimal total cost of procurement for the firm. So these are the items and these are the suppliers. So we have to assign in such a way that cost becomes the minimum. We have to optimize the cost. So you already know how to solve by Hungarian method. So let us solve. You have to perform row operation. Let's say for the first row 110 is the lowest one. So you have to subtract 110 from each and every cell. That is 0, and that is 10, and that is 20. For the next row 115 is the lowest one, which gives you 0. This is 25 and this is 25. Okay. For this one 125 is the lowest one, which gives you 0, and this is 20 and this is 40. Okay. Now you see all this row has got a single 0 value, but this column and this column are not having 0 value. That means you have to perform again column operation. So performing again column operation, you have to do a new table. Say this one is S1, S2, S3, and this one's a P, this one's a Q, and this one's a R. Okay. Now if you have to perform column operation, this remains same, 0, 0, 0, and this one is the least one is the 10. So this is 0, this becomes 15, and this is a 10. Okay. So now this in this row, in this column, 20 is the least one. We have to subtract 20 from each and every cell. This becomes 0, this becomes 5, and this becomes 20. Now you can see that you have got every row 0, at least a 0, and every column at least a 0. Now you can assign. How to assign? The first rule to assign is we are going in row wise. Okay. In going row wise, we have to assign the first 0. But since after assigning first 0, corresponding row and corresponding column is having any 0, you have to cross it out like this one. My mistake. I cannot assign to this row, as I earlier said that if a row contains more than one 0, you cannot assign to a single 0. So you have to skip that first row and you have to come to the second row. Okay, next row. So in this row you have more than one 0, so you cannot assign to this row. You have to come to the next row. Coming to the next row, you can see it has got only one 0, so you can assign it over here. So I am assigning this 0. This 0 has been assigned. Okay. Now assigning this 0, I have already earlier said that corresponding to this row or column, you have to cross the 0. This 0 and this 0, and this row has not got any 0. Now again coming back, you row wise operation, row wise not column wise operation, you can see that this column has got only one 0. Okay, so you can easily assign this value as, you can assign this 0. Okay, and corresponding this row or column, you have got only this 0, you can cross it out. Now second rule is you have to join all the zeros with straight lines. This is a straight line. Okay. So you have to join. Now you can see that over here this is a 3 into 3 matrix, but assignment over here is only 2. After performing row operation as well as column operation, you can see we have performed row operation as well as column operation to make sure that each and every column and row has at least one 0 in it, but we cannot assign 3 zeros, as because we are unable to assign 3 0, we have to again perform another operation. What is the another operation? You find it is the uncovered region. Over here is the uncovered region. You have to choose the least value among the uncovered region, which is 5 over here. Okay. Now this 5 you have to select. So you have to select this 5 and you have to add 5 to the junction of the straight lines, wherever is the junction of the straight lines. That is where the straight lines meet together. That is the junction point. You have to add 5 to the junction point and you have to subtract the 5 from remaining uncovered cells. So the new cells become somewhat like that. This is 5 as because this is the junction, the remaining remains same, and for this one you have to subtract 15. This is the 15 value, you have to subtract 5, which becomes 10, and this becomes 0, this becomes 5, and this becomes 15. You have to subtract 5 from uncovered region. Now you can easily assign the all zeros. Let us go row wise. Going row wise, you can see this row has 2 zeros, we cannot assign. Come to next row. Next row also having 2 0, we cannot assign. Come to last row, which is having only 1 0, we can assign, and in corresponding zeros can be cancelled out. Next come to column wise. This column is done. This column we have got 1 0. We are assigning this. Okay, assigning this, you can cross out the corresponding row column zeros. This is cancelled out. Now only this 0 can be assigned. Now as because 3 zeros are assigned in this particular problem, we have got 3 into 3 matrix. That means we have assigned all the values. Now let us find the transportation costs. Sorry, my mistake. It is the assignment cost. Look, P is assigned to S2. That is P is assigned to S2, which gives rupees value. P is S2 rupees 120. Okay. Now Q is assigned to S3. Q is assigned to S3, which gives you rupees. Q is S3 140. Next, R is assigned to S1. R is assigned to S1, that is giving 125. R is assigned to S1, giving rupees 125. Now these are the total assigned values. You can sum it up. You will get rupees around 385, which is the TC, and total cost is minimum total cost, you can say rupees 385. Okay, so this is the Hungarian method. We understand how to solve the assignment problems using Hungarian method, and we have find out the total cost, minimum total cost, that is rupees 385, by solving this matrix, this particular problem, which is came to GATE in 2006 paper, and we are finding that the total cost, minimum total cost, is rupees 385. Thank you.